Hey everyone, welcome back to my channel. In today's video, we're going to tackle an interesting problem from Leet code, longest substring without repeating characters. This problem is a common interview question, and it's a great way to test your understanding of strings and hash sets in Java. So, let's dive right in. First, let's understand the problem statement. You're given a string S, and you need to find the length of the longest substring without repeating characters. For example, if the input string is abcabcb, the longest substring without repeating characters is abc, which has a length of 3. If the input string is bbbb, the longest substring without repeating characters is b, which has a length of 1. If the input string is puq, the longest substring without repeating characters is yk, which has a length of 3. Our goal is to find an efficient way to solve this problem. Let's start with a naive approach. One way to solve this problem is to consider all possible substrings and then check each one to see if it has repeating characters. If it doesn't, we keep track of the maximum length. While this approach works, it's not efficient. Checking all substrings means we would be working with an O(n) cubed time complexity, which isn't practical for large strings. Let's briefly outline this approach. First, loop through each starting point of the substring. Then, for each starting point, loop through each ending point. And finally, for each substring, check if all characters are unique. We need a better approach. Let's consider optimizing it using a hash set to keep track of the characters in the current substring. Here's the idea: use 2 pointers, left and right, to represent the current window of characters. Expand the right pointer to add new characters to the window. If a character is repeated, move the left pointer to the right until there are no more repeating characters. This technique is called the sliding window approach, and it helps us reduce the time complexity to O(n). Let's walk through the solution with an example. Imagine our input string is abcabcb. We start with left and right pointers at the beginning of the string. We expand the right pointer, adding characters to our current substring and storing them in a hash set to ensure all characters are unique. Whenever we encounter a repeating character, we move the left pointer to the right until the substring no longer contains duplicates. Throughout this process, we keep track of the maximum length of the substring without repeating characters. Let's see the code for this approach. We create a hash set to store characters. Left and right pointers represent the window's boundaries. Max length keeps track of the maximum length found. If the character at the right pointer is not in the set, we add it and move the right pointer. We loop until the right pointer reaches the end of the string. If the character at the right pointer is not in the set, we add it and move the right pointer. We update max length with the maximum length found so far. If the character is already in the set, we remove the character at the left pointer and move the left pointer. Why is this approach better than the naive one? Efficiency. The sliding window approach runs in O(n) time complexity, making it much more efficient for large input strings compared to the O(n) cubed complexity of the naive approach. Simplicity. It uses a single pass through the string with a clear and concise logic, making it easier to understand and implement. And that's how you solve the longest substring without repeating characters problem using the sliding window technique. This method is efficient, elegant, and a great example of optimizing a brute force solution. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and hit the bell icon to get notified about future videos. Also, leave a comment below if you have any questions or suggestions for other problems you'd like us to solve.